Hello, my name is Charles, and today's video will be the Neuroscience of Learning Part 2. This is essentially the hacks, the cheat codes as they were, or the top 3 methodologies backed by scientific research and backed by neuroscience for how to learn. This will be helpful for any student, any researcher, or anyone out there trying to learn a new skill, new idea, or new practice. And a full bibliography with all the scientific research will be put in the description below, as long as a free and easy to use guide. So to start off with the first technique, this is called spaced repetition. And this is repeatedly reviewing previously learned materials at increasingly longer intervals. So this is effective for long-term memory formation. And essentially what this would be like is if we can imagine back to when we were in our childhood learning addition and subtraction, right? You learn it one day, and then you do a review maybe at the end of the day, and then you set a iPhone daily reminder, and you start reviewing it daily, and then maybe after 3 days you review it every other day, or every 3 days, and then you practice recalling it longer and longer, and it builds and consolidates into that long-term memory to help you remember what you need to learn. So what is some of the science behind this? Like, we've all heard the term like muscle memory, or if we're trying to shoot a free throw, or like, right? But muscle memory does not live in the muscle, it lives in the brain. And it's based on this idea of Hebbian learning. So neurons that fire together, wire together. And what is this process like? This is going to get a little nerdy, but it'll be good. It'll be juicy. So 2 neurons activate at the same time in that synapse, and the brain trail becomes stronger. So if you imagine, right, neurons that fire together, wire together. So one neuron, which is what's called the presynaptic neuron. Imagine this is like the person who texts first. So the first neuron, or the brain neuron that texts the other neuron first, goes, and then the other one, the receiver of the text, responds, and that trail between the two, as they keep texting each other back and forth, right, becomes stronger. And essentially by repetition, that neuronal pathway gets stronger. So the repetition builds the strength of these brain pathways. And if we have some questions about the brain, right, the brain contains 86 billion neurons with an estimated 150 trillion or so connections or synapses in the brain. And these, the 86 billion neurons, a neuron can have up to like 1,000 synapses, or like highways, right? People it texts almost, or other brain cells that it texts. So there's just tons of connections. And so it's a very, very complicated thing, but you can make new connections, right? And so what we can abstract out of that is that by learning things, having novelty, right, forming a new connection, that neurogenesis, and then revisiting them over and over, sending that text, creating that text conversation or that relationship with someone, if you imagine like 2 neurons like friends or partners or something, builds the strength over time. The second wonderful method for learning information is what's called interleaved practice is also a good method. It's basically where you take different topics or skills and mixed up during study sessions. So let's say you are studying math. And if we go back to this like addition and subtraction thing, while you're learning addition and subtraction, spice it up, learn a little, multiplication and division, and then go back to addition and subtraction and weave those two in between each other. And that creates a wonderful effect. In fact, there was a study done, and I will link the study down below, where they found what's called a contextual interference effect. So the brain scans showed that there was more functional connectivity, and so which led to better retention of the skills and ideas, aka the more you weave things together with different contexts, the more adaptable your brain has to be, the more it learns. So that's another technique. So let's say you're in coding or following my coding series. That would be like alternating between learning arrays in coding and then classes or for loops in classes, right? The more we weave things together, the more adaptable our brain has to be, and the better we learn. So last is the method of active learning, right? A comprehensive study found. And this is of the National Academy of Science, analyzed 225 studies comparing traditional lectures to active learning in undergraduate STEM courses. And what they found is 6% on average higher for exams in active learning, 1.5 times lower fail rate in the undergraduate STEM courses, and then it was consistent across all STEM, courses. So even in math, computer science, right, engineering, it's consistent that active learning, engaging in discussion and projects, those help you learn more than just being talked to or yelled at by the teacher. And so, and what now, you might be a little skeptical, like, what does active learning even mean? According to this study that analyzed the 225 studies, like the comprehensive analysis, they used the definition: active learning engages students in the process of learning through activities and discussions. It emphasizes higher order thinking and often involves group work. That's what they used. So the three methods we have learned today are active learning. And if you're going to do active learning, make it like project-based. So you learn a new concept or a cool new idea for coding. Make a project that applies to a real-world problem or challenge and try to solve something. You see that the ordering system at your high school or college is messed up, and you're like, lunches take too long. I'm going to code a way to order lunch early or make lunching better. That's a real-world solution to what's going on, and you'll remember the concepts better from your coding class. Second is discussion. Share your idea. Find a friend or a partner, someone who's willing to engage in discussions around these ideas. And if you can't find that, there are online communities on Reddit and so many other places where you can discuss your idea and engage with others. So next is for the spaced repetition. This is, put a daily notification on your phone. You learn a new concept, review it once, put a daily notification on your phone every day, review that new word, that new idea, that new coding idea, that new math, differentials or integrals. Write it down on your phone. Flashcards or Duolingo. Say you're learning a new language, just constant repetition. I got to remember it again. I got to active recall. I got to remember it again. The more you practice, in those different intervals of remembering, the better it gets stored. And then, when you set that reminder, you can even set a reminder to revisit your notes. Let's say you took notes during class. Set a reminder to look back at your notes. It doesn't matter if you put notes if you don't want to revisit the notes. Read what you wrote. And then for the interleaved practice, let's say if you're doing math, scramble the sets. If you're doing, let's say trigonometry problems, don't just do only sine problems. Do sine and cosine and tangent and scramble them all together. If you're doing addition and subtraction, scramble the addition and subtraction. Next, do rotating study sessions. Let's say, you have some science and you have some math as a college student. Do math for an hour and then do science for an hour, take a break, and then go back to the math and then do science and rotate them out to get that benefit where it's different contexts. And lastly, try to figure out how do these different disciplines or different areas of study connect? How do they all form a cohesive picture? How do they connect? Because that'll help you learn better. So this has been today's video on kind of the hacks, the tips, and the tricks based on the neuroscience for basically how to learn better, right? How to learn better. This will be useful for any student. This will be useful for anyone researching, right? And these are all scientifically backed ideas. And so, I hope this helped. Those were the three major tips. If you have any questions or comments or you want to see the research, it'll be in the description below. And even an easy to use guide or examples, if you need that, that'll be down below. Much love and have a wonderful, wonderful day.